Uno. Real study cases and the experience of the users. Thank you. Good morning. I'm going to speak Portuguese. It's easier for me. The idea here is to talk a bit about the implementation of artificial intelligence in ISP providers. Well, artificial intelligence is not new at all. You can go back many decades ago. However, lately it's been something that has been talked a lot because of the demand, because of the interactions in the networks, and also because of the tools available. So developing tools like ChatGPT, OpenAI, Cloud, and others transformed the way people have access to artificial intelligence, and consequently, the topic is it's important for us to debate this topic. So, based on a piece of research that I had access to, published by MIT today, over 80% of the initiatives of development of AI fail, and they fail essentially because of the quality of information available. So, it's not because of a lack of technology, but rather because of the lack of information that we have available. And so that is one of the key challenges that we have as we implement AI among operators. All right. So, first of all, let's discuss the potential positive impact that AI may have in an operator's operations. AI can bring a smart monitoring and detect anomalies in a more consistent manner. Instead of having alarms only with an interface or that the router has high processing, you may have alarms fed with context through different the data coming from different OSs or business in the company. You can also conduct predictive analysis in the network. That is, instead of reacting to problems, we'll start anticipating any potential problems and treating them proactively. The client's experience will also be optimized because we can solve problems faster and we'll have a lower incidence rate. And when we interact with the customer, we're going to end up with a much better experience, with better experiences with the clients. Through automation, we eliminate repetitive tasks among of the operators, and so the task can be done automatically and through integration of information of the different systems with the provider, either the ASS, BS with and monitoring. You have real-time monitoring of the network. The traffic increases here, so I must change the traffic, I must reroute it, or I must enable an interface, disable it. So all those are positive impacts that you may have because of the implementation of AI. However, we also have challenges that start with data, with the quality of data. If there is no quality data, if there is no information about clients, if there is no real source, if you don't know what clients are connected with each interface of the router, if we don't have information available about the information of the circuit per user, per interface, and associated data, there we have the first challenge. The second challenge is processing data in real time. The amount of information that we have in a network is significant, essentially in larger networks where we have more elements. So the amount of data may really be quite large. We may need a lot of resources to treat the information in real time. So the smart visualization of the metrics is a second challenge because we need to quit observing the data just as it comes from the machines and start giving the operator consistent information providing context. So, for that purpose, it is necessary to integrate data. How are we going to be able to tell the operator that the interface one of the router crashed? And if they don't know the clients that they were, if you don't have that information registered somewhere, so you need to integrate even if you have the information. So you don't need to put all the log in the router for the AI to analyze it if you can't integrate the database with the VSS system that provides the customer's information. And the third is the number of alerts, the information that you have, and how you don't lose that volume of information and you treat what is really important, such as providing priority to what is really relevant in the network. So those are the key challenges that you run into when you implement the systems. We are going to discuss those systems. We have implemented several of them in Edge Uno. Good. So, how do we start? For those of you who haven't started working with AI yet, we talk a bit about the impact because there are different tools that have different impact. Some are lower impact, some are higher. Here we have high impact, low impact, and tools that have a lower complexity when being implemented. You start with easier tools, easier to implement, for instance, that give you a smart visibility of the metrics, for instance, dashboard changes, sudden changes of traffic in the network. Those are tools that have a lesser impact and also a low complexity of implementation. There are tools that have a low complexity when deploying, for instance, prioritizing alerts. Those tools reduce the operation noise and bring more efficient responses to the knock, and and they have a impact in operations because you can scale operations up. There are also tools of predictive analysis that have all of them are highly complex, or their implementation has a higher complexity, and they have a more or less impact. And what's the difference? If you want to anticipate what will happen in the network based on events, that is quite complex. However, if you integrate that, or if you do not, if you correlate that with other RM, RP, or other systems, unless you do that, you won't. If you don't deploy the analysis based on operation data, you have a smaller impact. But when you integrate all the information, the impact is greater, both concerning the client's experience and the scalability of the operation. Now let's talk about the tools that we have used. In the automation environment, we use a lot of telemetry. Telemetry today is increasingly efficient. It's not just collecting log through syslog using GNMI or GNMIC. Not only can we receive continuous flows of data from the machines, but you can also import configurations, such as you can react to events. Ansible, N8N, and tools like netbox that provide us data on the connections in the network that are going to be enabled by automation so that they may work uneventfully. In the NOC part, we have advanced language models. Here we use the LLMs, the language models. We have experience using both OpenAI, ChatGPT, online versions, and trained local models, as well as local models using OpenWebUI, and the local models work the Open Web UI and like Olama, and then we'll discuss the costs. And when you have local models, not only do we have a security, data security and sovereignty, but it's also much more inexpensive. As to the smart, intelligent monitoring, all the tools such as Savix and LibreNMS are very important. Today they have very open interoperations with the systems that we mentioned earlier. So Acvorado is a tool that we have mentioned quite a few times, but we also studied it in tests to see the flow in the networks to complement the automation routines, not just with information, the up and down information about the network, but also showing the traffic profile of the network. For predictive maintenance, we have tools such as telemetry, the telemetry flow of the machines. Of course, the base is very important. We can use Prometheus as the database for storing the information, and others such as TensorFlow and Prophet for predictive analysis of the data that have been stored.
So now let us go back to the previous slide. Let us look at the integration of all this and how does this occur. Here we have the key issue, the key that we provide to do all this infrastructure, which is MCP. This is an open protocol to connect LLMs, data models, tools, and external models to LLM. These models, these AI models, basically, quite obviously, they are intelligent models. They have a lot of information, but they don't know their own network. So how do the network data integrated to the language models? We use MSP for that aim. It has three key components, which are the host, the client, and the server. The host is where the LLM it lives, where you connect with the user, you connect with the language model, the requests are made to the database, the client does a translation to the human language, you have the different APIs of the different systems, the databases, as well as different connection options that occur through the MCP server. This MCP server establishes the connection using all these tools and provides all this information to the database in order to establish the connection. This is a bilateral protocol. This is MCP server. You can do queries and you can also input information. All this is available in this implement model context protocol containing the repository of the information. Now, what is the ultimate aim here? The ultimate aim here is to get out of an environment where we have a manual operation and go over to an autonomous network that manages to do self-correction through automations, through language models, that the NOC operator can, in an automated way, have the context of the network. So this goes through integration with the LLM. This also has to do with mitigating the major incidents with automatic responses, in addition to enriching the type of response that can be obtained from the network. Instead of conducting an analysis and receiving fragments of information, and instead of one doing the analysis, we have a language model that does all this correlation of events so that we can receive enriched information. So this is our goal. Through the implementation of AI, the network can then go from being a manual network over to becoming an autonomous network. A little about tools. Regarding network monitoring, we have been using these tools over here. So what do we intend to do here? We want to not have an unstructured model, and we want to have a structured model. The unstructured model is when we simply conduct monitoring regarding the status of a port, the volume of traffic in an interface. Now, in the other case, we unify, we collect all the information, we create a context and take to the operation alerts that have a context. In other words, they inform what is happening instead of just stating that the interface has crashed. It has crashed because there's a degradation of the signal or something of that kind. Open Web UI is a language model interface. I said we're using Lambda as a local model. So we have all the orchestration of the various systems. The extraction, translation, and storing of the information is done used N8N. All this is then stored in a PostgreSQL database. And this is also an important part which we don't pay too much attention to. The network configuration should be part not only of not only include the logs, but this should also include training the models. We need to have configuration patterns. If we don't have all this information, we cannot correlate the source with what you have in the network. 2 days ago, a colleague spoke about what is your real source? Is this what you have in the system? Is it what you are configuring in the network? Very often these are different. So Oxidized is a system whereby we can centralize the sessions, and this has to do with the learning of the AI system. This is an example of an agent. This is an example of a laboratory showing what we can do. Over here we have the agent that orchestrates all this. This is the MCP server that establishes all the connections. It is in charge of all the orchestration. We also can have models with OpenAI, with AI, or with local models using memory variables in order to have the learning with the history of the events. We cannot disregard the previous events because these provide the context in the learning of the new events that we look at. There is integration with Netbox and all these others, Libre MMS and Greylog, NetFlow, and so on. This also with Postgres for storing all the information. All this is integrated, and through the output it can respond to webhook queries, queries on language models of LLM, or also provide outputs for the purpose of automating networks. If I have an X problem, please execute configuration Y. This can be integrated with telemetry, with Gemini, in order to compute the configuration with your elements. This has to be validated by the operator. That is the objective, going from a generic LLM that doesn't have the specific knowledge on the network over to an AI agent that has specialized and has the entire reasoning power of the LLM, in addition to the context of the specific performance of that network. With that aim, we have to feed the LLM with the data of the network. We have to train the LLM with specific data performance, nuances of the network. For example, on Wednesday, there is a football match. We're going to do live streaming, so we will have a peak in traffic. So the network has to know all these things. So we have to train the model with the performance of the network as well as optimizing it for local hardware. We have been very successful using basic CPUs and training the local models in order to control costs, which can be quite significant in those current platforms. This is the online models. So to close, we have pros and cons. Cons, or rather challenges for the purpose of the deployment. Regarding the pros, improved monitoring, more intelligent. We are capable of we have predictive maintenance. We can predict the events in the network. There is increased automation in the network. We have scalability, improved user experience, of course, with less events and with less incidents, and a more specialized response, in addition to cost and time savings. As to the cons, the potential initial high investment or high recurrent cost for training commercial models. You might have to invest in local hardware, and maybe not only invest in hardware, but also in knowledge and on human resources that have the necessary knowledge to carry out this deployment. We also have the integration challenges. Quite obviously, these data quality and consistent quality are essential for this to work. You cannot have an ecosystem deployed without reliable data. We also have the concern regarding data privacy. We recommend having local models with this purpose. There is a dependency on technology because insofar as we implement and are successful in what we do, we start to optimize the operations. Now, if this fails, we no longer have visibility of the network. So the absence of the system ends up being a problem to the system because we cannot work in the network manually. And there's also a need of having skilled staff, network engineers. They really have to be specialized in network automation, in software architecture. All those professionals and experts from the network area know that we have to change our mind on the networks, but also advanced knowledge on the tools that we can use so that that environment can be scalable. These experts, these professionals are more expensive, obviously, and also more scarce. This is not a con, but of course it's one of the challenges that we face. So this is our experience at our company at Edge Uno. So I am at your disposal in case you have any questions and tell you how we solve our problems. And thank you very much for your attention. Thank you, Epafras. That was a great presentation. It was wonderful. Any questions from the participants? Yes, over there, please. As usual, please introduce yourself, name and enterprise. Good morning. I'm Fernando from the city of Santa Rosa, Rio Grande do Sul in Brazil. I have a question regarding the curatorship. How, after the deployment of the deployment, do you do the follow-up? How do you deal with AI hallucinations, among other factors? In the beginning of your presentation, you said that 80% of the AI applications fail because of the data quality. That is quite true. We realize that that is the case. So regarding if you have a reasonable data quality, I nevertheless have to count on people who are in charge of that curatorship and can evaluate these responses to see whether the decisions were properly made. Do you use any tools today with an aim in addition to the human factor, or how do you carry that out? Well, initially, we started to do so with the deployment of scripts using Ansible in Python in order to standardize the configuration. So we implemented a standard regarding the configuration of the devices. We implemented routines to identify deviations. This guarantees over time that the configuration is consistent. If there are any deviations in the configuration, there is an alert, so you can guarantee the quality of that configuration. The second point is integrating the SRM systems, the BSS. These are an essential source of the information. So when we see the client's commitment, the customer's commitment of what they can do, then we need to have consistency in the network configuration and how these CRMs appear. So once we manage to achieve that integration, we create routines for validation purposes. What is the truth of this? This is what the customer will ultimately pay. We need to adjust the network. We can have inconsistency, but we have to deal with this in a different way. Now, when we create or before we start with the LLM, there's a sequence of routines that has to be created to have a consistent model. 2 years ago, we have been working on this for 2 years now, and we now say, well, now I'm ready, so that the NOC operator with the LLM can do an interface model.
Douglas, Sam, you said something that really struck me, and it is the need for integration. I think that there's a huge problem in the telecom world. That is the dichotomy between the DTI and the telecom, the TI and the IT and the telecom worlds. They are constantly fighting. They think the other one is evil, and you said that what you mentioned what the truth was, and in your model you explained it very well. You explained the different feed flows, but I felt that there was something lacking, and I don't know whether you want to fit that in the Edge Uno market segment, but the data on the quality of the user's experience. Let me see. From the point of view of the ongoing operations of the network, it's very good. However, I'm going to add another variable, another feedback. The network says that everything is okay, but the users don't agree. They say that it doesn't run so smoothly. So that is a potential input of data. So how can you dose the input of information that sometimes do not seem to be reliable? A classical example, the vector, that this is true. How does that fit in the model? Well, it will pretty much depend on the way the client interacts with you. We have consistency. Client interaction is done through tickets, and that is done both for ACM and tickets, and we integrate our tickets as part of the ecosystem. We are not there yet, but we want to evolve for a predictive analysis of the client's behavior. This client has a certain number of claims, so we are going to raise it so that you can improve your relations with the client. But all that is part of the integration, because it has to be in the system. You can't have it in a WhatsApp conversation with the CTO. Thank you. Thank you, Pafras. A round of applause.